for you to understand before we get to other important theorems. So this is the question which is about Euclidean geometry, and inside this Euclidean geometry we're given a center O, of which inside the cycle we're having two triangles. So it's triangle O, let me see, ACO, and triangle ABO. So we're given two triangles. So now, with that information, we are told that if A1 is equal to 30 degrees and B1 is equal to 50 degrees, find A2, O2, and O1. So the question is, how do you find O2, A1, and O1? So you need to study the information that you're given from this triangle. So it's a matter of remembering the theorems that we have covered already with other theorems from grade 9, which are important. Let me remind you of those theorems because they are important. Let me see what this person is saying. Okay, no, it's okay. Let me remind you about just one theorem, which is very important. If we are having these two sides which are equal, what can we say about the angles we have down here? The angles opposite to equal sides, they are what? If you remember the theorem from the 9, it talks about the opposite angles of the equal side. What does it say about the opposite angles of equal sides? If you remember, okay, you don't remember the theorem, eh? So, but it's the theorem we're going to use in this case, that if we are having opposite sides which are equal, that simply means that the opposite angles of these triangles are going to be equal. So this yes.
Will it be possible for you to start from theorem 1 until 9?
Yeah, I can remind you about all the theorems so that we don't lose each other in this case, because they're important, all of them. And in order for us to answer questions, we need to remember the theorems. Okay, we are agreeing that I must start from theorem number 1. Is that so?
Yes.
Okay. Now, let me start with the ones I've covered with you the last time. Of which, but this theorem, I mean, this question I'm not having it because I want to answer it with you because it's a very, very important question. Theorem number 1. So we are given a cycle, and inside this cycle, we are getting the center, which is center O. So now, if we are having center O, we can then construct a triangle like this. We can construct a triangle like that. So in other words, it's a triangle with radius from the center to the circumference. So these are the radiuses, of which you must all be able to see that we are given radius. So let's say this is a triangle ABC. So from that triangle ABC, we then construct a line from the circumference of the circle to the center of the circle. Again, from here we construct the line from the circumference of the triangle to the center of the triangle. So why are we doing so? We want to come up with a theorem that talks about the angle we have from the center of the circle to the circumference of the circle. Are we all together? I just want to make sure I'm with you up to so far. Are we all together with regard to this construction I've made just now?
Yes.
All right. Then now there's a relationship after constructing this triangle. There's a relationship that we have established. What is that relationship? Is the angle at the center of the circle that relates with the angle at the circumference. So now this theorem, it says that angle at the center of the circle is twice the angle at the what? At the circumference. So this angle we have here at the center of the circle is twice the angle at the circumference. At all time, this theorem applies, wherein the angle we're given at the center is twice the angle at the circumference. So you can even write it in this way, that the angle at the center of the circle is equal to 2 times angle at circumference. It's a theorem which you must not forget even a single day. But this theorem is having an extension. What is the extension of that theorem? It's when we construct another line again. So from the end of this triangle, and it joins the other end of the triangle like this. So we have formed another angle now. So is this angle we have here? Let me say is angle D, and then again remember that we have O1, and then now let me call this E2. So O1 is equal to 2 times A, but now there's another relationship we're establishing that uses exactly the same principle of the angle at the center is twice the angle at the circumference. But this time around, we're going to establish that theorem by using angle O2. So O2 is equal to twice what? Twice D, twice angle D. So again, it's this theorem. Angle at the center is twice the angle at the what? At the circumference. So now, whenever you talked about this theorem, you must remember that it starts from the center of the circle. If we don't have center of the circle, this theorem does not apply. Are we all together with regard to the first theorem I've introduced to you just now?
No.
All right. Can I repeat again?
Yes.
All right. Let me repeat. So there are 2 theorems I've established now. Even though we can say it's one theorem, but in actual fact there are 2. So the first one is when we are having a triangle ABC, and then from this triangle we establish or we construct a line from the circumference to the center of the circle. Same here, we construct a line from the circumference to the center of the circle. So the reason why we're doing that is because we want to establish the relationship between the angle we have here at the center of the circle. So it's O1, and we want to relate this angle with the angle that we have at the circumference of the circle. So now the relationship that we have established here, it says that O1, which is the angle at the center of the circle, is twice the angle at the circumference, of which if we say O1 is equal to 50, what does it mean about, okay, let's say this is 100. What does it mean about A? What does it mean about angle A? If O1 is equal to 100, what does it mean about angle A? If you understood the theorem I gave you now, if O1 is equal to 100, what can we say is angle A? Angle A will be equal to
100.
If O1 is equal to 100, what will be angle A? Let's use this principle that we have.
200.
You said it's equal to 100.
200.
O1, O1, I said is 100. Ne? If O1 is 100, what is A using this principle? Okay, let me do it for you just now. You're going to do the second one. O1 is 100, and then we equate this to A. And now we want to calculate for A. How do we get A? We divide both sides by 2, and we're going to obtain what? 50. Do you see that?
Yes.
A
Yes.
is equal to 50. Okay, I tricked you because I said O1, but it's going to be simple for you if maybe I say, yeah, if I say A is equal to 20, what would be the angle for O1? O1 will be equal to, if A is equal to 20, what would be the angle O1? O1 will be equal to what? Any idea?
What? I'm not sure.
Yes, you are very right. It's equal to 40. Where this comes from, it comes from this theorem I've covered with you. That angle at the center is equal to 2 times the angle at the circumference. You must not forget that theorem. So it's the same thing which applies on this other shape we constructed down here. That this angle O2 is going to be twice D, twice angle D. So you must not forget even that other part of the theorem, which is called converse. It's a converse of the theorem that we have up here. Can we go to the theorem number 2?
Yes.
All right. Let me introduce theorem number 2 just now, which is about 2 triangles. You can see we are dealing with 2 triangles inside the circle. So now, let's say we have this triangle here, and then other triangle. So here we have triangle A, B, C, and here we have triangle D, E, F. And then now, the assumption is that we are given that AB is equal to DE. AB is equal to DE. Then the question is, what can you say about angle C and angle F? Angle C and angle F, they will be what? Angle C and angle F, they will be what? And what's the reason for that? Any idea? Okay. Let me tell you the answer, but I'm not sure if you are.
Are they not equal?
They're going to be equal. And what's the reason for these two angles to be equal? Why are they equal? Because they are what? They are subtended. These two angles, they are subtended by the same or equal. Let me use equal. By the equal sides. They are subtended by the equal sides or equal chords or same chords. It's the same thing. So these angle C and the angle F, they are equal because they are subtended by what? By the same chord. Are we all together?
Yes.
All right. Let me do the converse of that theorem again. So the converse or the similarity of the above theorem is when we are having this kind of shape. So you can see the relationship here. So we have A, we have B, and then we have C, and we have D. What can we say about angle D and angle C? What can we say about angle D and angle C? Any idea? What can we say about angle D and angle C?
Opposite equal sides, but I'm not sure.
They are equal side. They are equal. These two angles are equal. Why are we saying they are equal? We're using still the same theorem up here. So, but let me explain to you of how we arrived to this conclusion. So now let's see. This angle here is having which side? It's having side AB. Do you all see that? Angle D is having opposite side AB. And then again, C. What is the opposite side to angle C? What is the opposite side to angle C? Do you see that is the same? It's AB. Do you all see that it's the opposite side to C? The opposite side to angle C is AB.
Yes.
Yeah, exactly. So that's why D is equal to C. We are using this theorem that if we're having two sides in the opposite angles of that, they must be equal. So it's the same here, it's the same theorem. So here it's subtended by the what? By the equal chord. Now we can use the word chord because it's an obvious that the side that is given there is a chord. Then now another important theorem, let me write here, is theorem number 3, of which is the last theorem I introduced to you the last time. It's when we are having the center of the circle, and then there's a line that passes through the center of the circle. What is the line that passes through the center of the circle and it goes to the circumference? What do we call that line?
Tan radii. I'm not sure.
Can you try another? The radii is, it goes from the center to the circumference. That one, the one from circumference to the circumference, but it passed through the center of the circle. What do we call it? What do we call that line? Which passed through the center of the circle, it goes from circumference to circumference. Is the diameter, right? You must not forget the names of all these things. Is the diameter. So therefore now, if we're having the diameter, and then we join the line that goes to the circumference like this, and it forms a triangle, then now it's known that the angle that is going to form there is 90 degrees. Are we all together? So the angle that is going to form here is going to form a 90 degree. Only if this is a diameter. If it is not diameter, that's not the case. So if we have triangle A, B, C, then C is going to be equal to 90. Why? Because it's subtended by the diameter. Subtended by the diameter, not the chord. You must know the difference between the diameter and the chord. So here it's subtended by the diameter, like that. So it forms a 90 degree. And it can be other way around. If you are given that this angle here is 90 degree, then you must know that it's a diameter that you have down. Okay. That is the information which I want you to know now before I do this example. So I'm going to do the example, and then after the example, I then introduce the remaining theorem. There are 12 of them in total, of which you are required to know all of them from grade 11, and then I'm going to introduce the other ones which are for grade 12, which are only 6. So if you know all the 18 theorems, I can tell you, you are not going to have any problem with Euclidean geometry, because this chapter is about remembering all the theorems. Once you remember all the theorems, you're going to get the answers correct. It's a very simple chapter, which I want all of you to get total. And it comes with a lot of maths. So you just need to remember the theorems. Are we all together?
Yes.
Can we do the question for the day? This one. All right, let's do this question, which is about finding the angle A2, O2, O1. Okay, before I say anything, is there anyone who can be able to tell me about the theorems you can see from this diagram? Which theorem can you see from the diagram? Before I say anything, you must be able to spot out the theorems that we have on that diagram. Which ones can you see?
Theorem 1, I'm not sure.
Okay. Let me quickly do the question with you so that we are able to cover other theorems for the day. We are given, if you don't understand, don't hesitate to let me know because I'm here to make sure you understand everything that we're covering. So we're given that A1 is equal to 30 degrees, and we are also given the B1 is equal to 50 degrees. This angle is equal to 50 degrees. And we are required to find angle A2, O2, and O1. Now, with regard to that, we need to remember this theorem, that if these two sides are equal, therefore the angles opposite to them, they must be what? They must be equal. Then now, let's check here. What is this distance from O2 to B? What do we call that distance? The distance from the center of the circle to circumference, what do we call it? What is the distance from the center of the circle to the circumference? Is the radius or radii. This is the radius, of which you can see that is exactly the same as the distance from O to A. So you can now claim that OB is equal to OA. So if anyone asks you, why do you say OB is equal to OA? Then the answer to that is that because the two sides are the radius, or they are radii. Are we all together with regard to the first claim that we have made there? Are you here?
Yes.
All right, that is fine. So now, and once we get this right, we can be able to talk about the angle that we have here with the angle that we have here. So B will be equal to angle what? Can anyone tell me what can we say about B with regard to the other angle? B is going to be equal to angle what? B will be equal to angle A. Why? Why is it equal to angle A? Because OB is equal to O what? OA. Is this theorem that you have? Are we all together?
Yes.
All right.
Yes.
Okay, wonderful. B, it would be equal to A because the opposite, if two sides are equal, then their opposite angles they must be equal. That's why we say B is equal to A. But we know A in this case is given as A1 plus A2. That information we are given that A is A1 plus A2, of which B is given. What is B here, or B1?
It's
B is 50 degrees, and A1 is also given. What is A1? Is 30 degrees. Therefore, we can be able to calculate for A2, of which A2 in this case is going to be 50 degrees minus
20.
Therefore, the answer on that question is what? It's 20. Are we all together? We are now having the answer for A2, which is 20 degrees. We are now having 20 degrees for A1. All right, let's now go to the next question, which is about calculating. What are we calculating? We are calculating for O2. Let's find this angle O2, this one here. What would be the angle O2? Is there anyone who can see the theorem that we can use with regard to finding the angle O2? Which theorem can we use?
Sorry, can you repeat that?
Which theorem can we use to find angle O2? Which theorem can we use to calculate angle O2? All right, let me assist you with that. Okay, now already we are having an information about B and about A. Then with this information, we can be able to calculate O3. Do you all see that? With that information, we can be able to calculate angle O3 because we know that A plus B plus O3 is equal to something. These three angles, if we add them together, they're going to be equal to what? They will be equal to? They're going to be equal to 180 degrees. Why are they equal to 180 degrees? Because all
Isn't
angles,
it angles in a triangle is equals to 180?
yes, these are angles inside the what? Angles inside the triangle. As simple as that. That's why it's equal to 180. And from there, we are given
Angle.
angle A, of which is 50 in this case. That's all. Plus B is also given is 50 plus O3, of which this will be 180. Therefore, O3 will be equal to 180 minus 100, which is 80 degrees. And that is our O3. But the question doesn't require us to find O3. It requires us to find O2. So finding O3 is just assisting us in finding the answer for O3. Then now, let's again make a claim about C1. Remember, we want to get O2. Let's first get angle C1, and then from there, we're going to get to O2. So now, there's a relationship about angle A1 and angle C. So these two angles, they're going to be equal. Why are they going to be equal? C1 is going to be equal to 30 degrees. Why? Because they are subtended by the what? By the radius. So OC is the same as OE. Therefore, they are subtended by the same size, of which simply tells us that A1 will be equal to C1. Why is C1 equal to 30? Is because OC is equal to OA. Or if you want to write it in other language, you can say radi. Equal radi, sorry. So you say equal radi like that. And after getting C1, can you quickly calculate O2 for me? I want to see if you are following. Can you quickly calculate O2 for me? I'm giving you just 2 minutes to do that. What is O2? What is the value of O2? Quickly tell me the value for O2. O2 will be equal to what? O2 is equal to any idea what is the value?
Can I try?
Yes, quickly try.
What if I say O3 is equal to C1?
Yes.
And then it would be 50.
I did not get the last part of what you were saying.
Oh, angle O3 is equal to C1. So in 80 minus 30 will be 50 corresponding angles. Not sure.
All right. Yes. Okay. Let me quickly answer that question. Okay, you raised another important thing of the corresponding angle and alternate angles. Let me quickly explain that to you because it's something which is very important that you do in grade in grade 9 and grade 10. So those two theorems that apply only when you are given two lines which are parallel to each other. If you don't see any lines which are parallel to each other, don't think about this theorem, even in single time. So now, let me quickly explain to you that this angle here, it will be equal to that angle, only if these two lines are equal. Why? Because they are corresponding angles. Are we all together?
Yes.
Yes. You must be given two parallel lines, and then if they are parallel, then this angle here will be equal to that angle because of the theorem of corresponding angle. And then the second one is for what is called the alternate angle. So again, you must be given two lines which are parallel to each other. Then for this angle here, it will be equal to the angle down there. Why? Because these are the corresponding angle. But the key is that the two lines must be parallel to each other. We are together on that one, right?
Yes.
And then the last one is for what is called the interior angles. That applies when you are given two lines which are parallel to each other again. So the angle down here, if you add it together with that angle, they must be equal to 180 by using what is called the core interior angle. Again, you must have two parallel lines. So here you can see we are not given any parallel line. So you must not think of these three theorems I've covered with you just now. So let me take you through this question, and then we will go quickly to other important theorems which I want to cover with you. Okay, time is moving very fast. This meeting is left with about 3 minutes, but let's log into the other meeting immediately after this one finishes. So I'm answering the angle O2 now, which is this angle that we have. So already we find angle O3, which is what? O3 is 80 degrees. So now let's first get C1 before we get to O2. C1 is 31 because we have two radius. And now with that information, we can then be able to calculate for O2, of which we can get it by saying O2 plus O3 plus C1 plus A1. This must be equal to 181 because these are the angles inside the what? Angles inside the triangle. As simple as that. All the angles inside the triangle ACO is equal to 180 degrees. So it's O2 plus O3 plus C1 plus A1. All these angles, they must be equal to 181 because all of them are angles inside the triangle. Are we all together with regard to that information I gave you just now?
Yes.
All right, then from there we substitute so that we get O2. So we're going to have O2 plus O3, we get it as 30 degrees plus 30 degrees plus A1 is 30 degrees, which is equal to 180. Therefore, O2 will be equal to 180 minus 90 degrees, of which this will be O2 equal to 90 degrees. I believe I've done it correctly. Here is stated, there is stated, there is stated. That is correct. All right, then from there, we go to O1, which is this angle. I believe you remember about the angle on a straight line. What is the angle on a straight line? What is the angles on a straight line? This angle here is equal to what? 180 degrees, right? So now if we add O1 with O2 and then with O3, these are going to be equal to 180. Where this information is coming from? This information is coming from the angles on a straight line, as simple as that. These are the angles on a straight line, of which you can